Hello folks, we come to the part 4 video of this exercise 5.3. Again, these are all inverse trigonometric functions. We are going to use an intelligent substitution, and that's how we are going to get the values over here. So they say that this function y is cos inverse of 1 minus x squared by 1 plus x squared. We know that cos 2 theta is 1 minus tan squared theta by 1 plus tan squared theta. Because you know that we are going to make a substitution x as tan theta, and let's see how this is going to help us. Let x be tan theta, which makes us clear that theta is tan inverse of x. So what happens to y? Y becomes cos inverse of 1 minus tan squared theta, because x has become tan theta now. 1 plus tan squared theta, and by formula we know that this is cos 2 theta. So since this is lying in the domain cos inverse and cos, that is an identity function, and you're left with 2 theta. 2 theta for us, because we know that theta is tan inverse x. We're taking the derivative on both sides. Dy by dx is 2 times derivative of tan inverse x, which comes to 2 by 1 plus x squared. That's all. Yeah, that is the derivative over here. It comes as 2 by 1 plus x squared. I don't know if you like checking it. That's correct. So we are going to the next problem, very identical. It is sine inverse of 1 minus x squared 1 plus x squared. Now here there is a bit of a problem, because 1 minus tan squared theta by 1 plus tan squared theta is cos 2 theta, and sine inverse is there. Generally it tallies, but in this case it is coming like that. Anyhow, let's go in for that substitution, because we don't know any better substitution. So let x be tan theta. So theta becomes tan inverse of x. What happens to y? Y becomes sine inverse of 1 minus tan squared theta by 1 plus tan squared theta, which is sine inverse of cos 2 theta. Now every time we used to get these two identical, so we used to get it as identity and we could work. But now here it is not coming, but still we are happy and lucky. We are lucky that we have got a complementary function. Cos is a complementary function of sine. So what happens is, we could always write this cos 2 theta as sine pi by 2 minus 2 theta. We have learnt it, that any function pi, cos and sine, they are complementary. So if it is cos 2 theta, we can always write it as sine pi by 2 minus 2 theta, and vice versa. We can do it like that. So instead of writing cos, we will write sine, but the complementary function. Our intention is to get the identity over here. So what happens is that, because sine inverse and sine, they are inverses of each other, get the identity. So we are left with just 2 pi minus 2 theta. What happens later is pi by 2 theta we know is tan inverse of x. This is y. Now we take the derivatives on both sides. So it is a derivative of pi by 2 minus 2 tan inverse x. So that is derivative of pi by 2 minus 2 times derivative of tan inverse x. Pi by 2 is a constant, so derivative is 0, and 2 derivative of this is 1 by x squared. Your answer minus 2 by 1 plus x squared. It's minor difference between both of them. One minus has come. That's about it. Right? We'll take the next problem, where they say y is cos inverse of 2x by 1 plus x squared. Now this itself prompts us, because cos inverse of 2x by 1 plus x squared, again if you could substitute x as tan theta, you would only get sine 2 theta. That's a formula for sine 2 theta. Again we'll have to use this kind of a logic, and we can come back, but lucky enough, at least we're getting complementary functions. So to start with, let's call x as tan theta. So what will happen? Automatically theta is tan inverse of x. What happens to y? Y is cos inverse of 2 tan theta by 1 plus tan squared theta. This by formula is sine 2 theta. Same problem is arising. Complementary functions are coming. We're not getting it identity directly. So we will do one thing. In order to make things simpler, we will call this as cos pi by 2 minus 2 theta. What is the advantage? That cos inverse and cos, they are inverse functions, so you can reduce it to identity function, and as a result we are left with pi by 2 minus 2 theta. That's our y. That way we can find the derivative. Dy by dx is going to be d by dx of 2 times tan inverse of x. So pi by 2 minus 2 times tan inverse of x. So when you take the derivative, it is d by dx of pi by 2 minus 2 times d by dx of tan inverse of x. Constant, so derivative is 0, 2 times, it is 1 by x squared. Your answer minus 2 by 1 plus x squared. Yeah, so that's what is happening over here. Intelligent substitution is going to give you the answer. There are some more problems left that we are coming with it in the next video. Thank you.